Okay, good morning, class. Right. So, can you open the link, the class point activity? Okay. This is the link. Okay. For a moment. Okay. So this is the code 15150. Okay, one more person. Where is it? Where is weekend? Is already here, is it?
Teacher, my internet a bit slow.
Oh, okay. Okay. Right. Thank you. Okay, so yesterday I promised to you that we will do some question for the damping oscillation, right? So can you try to please answer this question? Okay, three more. Who is it? Tava, Nirupa, Lakshmi. Okay, so let's check the answer. D D B A. Okay, maybe. So that's a lot of answer. So mostly you got A, okay, but some answer B and also some answer D. Okay, so let's see the correct one. So it says the diagram below shows an oscillating system.
Teacher, that's not the question.
Sorry. This one, right?
Yeah.
This one. Yeah. No, this one. Wait. This is the question, right?
No, yes,
No,
yes.
this teacher showed just now number 3.
Number three. Yeah, this
This
one.
one, this one.
Okay, so it said diagram below shows the displacement time graph on oscillating spring, right? So the oscillating spring it undergoes a damping oscillation. If force oscillation means the load, right? The load we keep oscillate. Okay, we keep oscillate, but this one you can see the amplitude is decreasing. So this one is actually a damping oscillation. So the answer is A. Resonance, we didn't learn yet, but if resonance, the amplitude will be same. Okay, the amplitude will be same. There will be no decrease in amplitude, right? So the answer should be A. This is the graph for damping oscillation. Okay, next one.
Janet, you're muted.
Yes. Okay, three more person. Abi. Okay. Right, so let's check the answer here. Okay, so it says here diagram below shows a graph on oscillating system. Okay, experience a damping. So which of the following quantities does not charge? Does not change. So this one, we know the amplitude is decreasing. Okay, but the period of the frequency is same. Right. So the answer should be B. Okay, period or frequency must be same. Okay, amplitude and energy will change. Amplitude and energy will decrease because the amplitude is actually represent the energy. Okay, so the answer should be B. So let's check your answer. D. Amplitude does not change. The amplitude is changed, right? You can see the size of crest here is decreasing. Okay, so the answer is B. B. Tava, the answer is B. The answer is B actually. Okay, the period and the frequency. Ketiga, C. C and amplitude. Amplitude change, right? Okay, so the answer should be period or frequency, right? Okay, this one ready answer. Okay, Sajib. Okay, so let's check the answer. Okay, A, C, B, mostly answer A. Okay, only B and C. One B and one C. Okay. Alright. So it says diagram below shows an oscillating system. Which graph shows the correct relationship between the displacement and time for the oscillating system? So you can see here the amplitude, right? The amplitude will change. Okay, it will decrease because you already see there's water here. So means there should be the water refraction. Okay, so the water refraction means the energy will be lost. Okay, because if you want to oscillate, you have to overcome the water friction first. Okay, so you have to overcome the water friction first, so there will be energy loss to overcome the water friction. Okay, jadi so the answer should be A, right? The answer should be A. The answer is A. Okay, so next one. Okay, so when amplitude of wave increase, okay, it's what? So amplitude actually represent what? Okay, so already answer. Energy will increase. C, B, A, C. Okay, so there are A, mostly answer A, B. A and B. Okay, Q answer C. Right, so let's check the answer. So when the amplitude of wave is increased, so means the energy also will increase. So remember I told you just now, the amplitude is actually represent the energy. So when the amplitude increase, the energy also will be increased. Okay, so remember amplitude will amplitude increase, energy also increase. Because amplitude represent energy. But in the damping oscillation, okay, in the damping oscillation, when the amplitude is decreased, right, you can see there is a decrease of amplitude, right? So means the energy also will be decreased, right? So that is the damping oscillation. Okay, so the amplitude will be decreased because it has to overcome the air friction. Alright, so there will be the energy lost to the surrounding. So that's why the amplitude decrease. Okay, so let's move on to another one. Okay, you have to determine the amplitude. What is the amplitude here? The amplitude of the oscillation in diagram A. So it means using this diagram. What is the amplitude here? Okay, Tava. Okay. Alright, some answer 2, some answer 1.2, 0.6, 1.2, decrease 0.6, 0. Okay. So remember just now, what is the amplitude actually? What does it mean by the amplitude? The amplitude is the maximum displacement. Okay, the maximum displacement from the equilibrium position. So where's the equilibrium position here? Here, right? Okay, so let's say if you don't give any force, or maybe after it's oscillate, okay, it will stop. So it will stop at this position. So this is called as the equilibrium position. Okay, so the amplitude is the maximum displacement. So the maximum displacement is actually from equilibrium to the maximum displacement is from here to here. This is called the amplitude. This is also called as the amplitude. Okay, so this one already give you 1.2 from here to here. So if this is the amplitude and also this one also the amplitude, the value must be same. So 1.2 divided by 2, so this one is 0.6, 0.6. So actually the amplitude is 0.6 meter. Okay, the amplitude, okay, remember we just learned to yesterday, right? So the amplitude is from the equilibrium position to the maximum displacement. So the maximum displacement is until here. Okay, so this is called as amplitude. Alright, so are you clear?
Yes, teacher.
Alright, okay. So move on to the next one.
Teacher,
Yes?
Kritika asked if we could show the diagram B.
Okay, wait. Okay. Alright. So let's check the answer. Dam oscillation, force oscillation, force oscillation, dam oscillation. Okay, so let's see the answer here. So complete the statement below by ticking, okay, the correct box. Okay, so let's see the graph here. It said based on diagram B. So on diagram B, you can see the amplitude is decreasing. So amplitude decreasing is what? Damping, right? Okay. So this is the graph for damping oscillation. Force oscillation, this is not the graph for force oscillation. Okay, this is the damping oscillation. Every time you see the amplitude decreasing, this is about damping. Force oscillation, there is no way for it, okay, to stop, okay, because you keep giving the force to the system, alright. But this one you can see it become decreased by time, right? So means there is no force, okay, given to the system. So this is not a force oscillation. This is a damping oscillation. So every time you see the graph like this is the damping oscillation because the decreasing in the amplitude here. So see the amplitude decrease. Okay. Alright, next one. I thought you already have this paper, right? Oh no, this one no, you don't have. Because this one is actually I just added in the notes. Okay, so I will show the diagram. Right. Period and frequency. Okay, so I will put the question here. Okay, C1 if I'm not mistaken. D1, D2. D1 is period. Find the period. D2 find the frequency. Okay, and C is you need to state the physical quantity that is not changed. Quantity I put here. Cannot like that. Physical quantity not change.
Teacher, the frequency formula is still the same, right?
Yes?
The frequency formula is still 1 over T, right?
Yeah, 1 over T. Okay. Want to check. Okay, 6, 10 more. Three more, two more. India, Avinash. Okay. Right, so C, time, mass, time. frequency, time, energy, period. Okay. Mostly answer time. Okay, time. Okay. Actually, there's no time. That is period. If you already submit, cannot erase. Okay. Alright. There's no time. That is actually period. Okay. So what is the physical quantity that remain constant? So the quantity that remain constant is actually period, not time. Okay. So not time. It's a period actually. So make sure you use the correct term, right? Period. So determine the period of the oscillation. So the period is actually two semicircles. So from here, two semicircle, right? So 0.4. Okay, 0.4. So the answer is 0.4 second. Alright, so what is the frequency? So frequency is F equals to 1 over T. So 1 over 0.4, you will get 2.5, I think. 2.5 hertz. Okay, so the unit is hertz. Okay. This is the answer. Okay, so make sure you use the right term. Okay, so move on to the next one. Okay, so at 11:30 I will stop. Okay, so it's time for you to present after that. So just now for M already present. Okay. So make sure you already prepared. Okay, your mic working, your video is working. Okay, maybe you can open your laptop because some said laptop are lagging. Okay, so something like that. So open, prepare, okay, and maybe you can just open your PowerPoint because I just switches randomly. Right? Who will present after this? Okay, so let's see the next one. So you already learned about the damping. Okay, you already know the graph of the damping. Okay, so amplitude is decreasing, the period is constant, the frequency is constant. Okay, why the amplitude decreasing? Because the energy is used to overcome the air friction, and then the amplitude is actually represent the energy. Alright. And then, okay, amplitude, you already know what's the amplitude. Amplitude is the maximum displacement from equilibrium position. Okay, so what is the maximum distance? Okay, that's your pendulum. Okay, can oscillate. Okay, so that is the amplitude. Alright, so we move on to the next one. Okay, resonance. Okay, so let's see the video here. So this is the button pendulum. Okay, so you can see it's oscillate. Okay, so let's try to play it again. Okay, so here you can see there are few pendulums. Okay, there are 5, I think. 2, 3, 4, 5, 6. So this is actually 6 pendulum. Okay, 6 pendulum. Okay, but this one is the mass. Okay, the length is same as this one, right? So if you notice, okay, the length is same as this one. Okay, so means if the length of this one same as this one, so let's say if I label it A, B, C, D, E, F. Okay, so let's say if the A is actually same as D, I think E, right? Same like E. Okay, so if the length is same means they has a same frequency. Okay, if they have the same length means they have the same frequency. So when let's say the bottom pendulum A start oscillate, okay, so when it oscillate, it will transfer the energy. Okay, so it will transfer energy to pendulum B, pendulum C, pendulum D, pendulum E, and pendulum F. Okay, so when the energy being transferred, okay, so all of this pendulum will oscillate also. Okay, but the amplitude means how far you can go. What's the displacement? Okay, what's the amplitude here? It depends on the frequency. Since the A have the same length with E, okay, since A same length with E, okay, so means they both have the same frequency. So E will oscillate in the maximum amplitude. Okay, it will oscillate with maximum amplitude, okay, because it has the same length as A, and it means they have the same frequency. So this one we call it as the natural frequency. They have the both of it have the same natural frequency, so both of it will oscillate with maximum amplitude. Right. Okay, you can see this one they oscillate in the maximum amplitude. Okay, so this is the experiment, okay, that we see just now, right? So it says here the tie a rope to two retort stands as shown in diagram 1.15. So the retort stand must be strongly clamped, okay, to the bench of the laboratory. Okay, so tie all the pendulums A to E to the rope. Okay, which two of the pendulum will have the same length? So actually, which two of the pendulum will have the same length? A, B, C, D, E. Which one? Which one will have the same length?
D and C.
So D and C. So you put the answer here, D and C. Okay, and which two pendulum have the same natural frequency? Right, so of course the answer is D and C also. Because I already told you just now, when they have the same length, okay, means they have the same frequency, and we call it as a natural frequency. So actually everything, okay, every object or every object that's around that, okay, in front of us, okay, they have their own frequency. Let's say you have a glass, okay, you have a glass okay, on your table. Okay, let's say when you sing, okay, so if you can sing, the frequency of your sing can be same as the frequency of the glass, okay, the glass will break, right? So that we call it as a resonance. Okay, so means you can sing with the same as the natural frequency of the glass. Okay, your singing can be reach, okay, can reach the natural frequency of the glass will break. Okay, so that is actually called a resonance. So same concept using here. Okay, D and C have the same length, so means they have the same natural frequency. Alright, so when you oscillate, okay, let's say here you oscillate C. Okay, let's say you try to oscillate C. So when you try to oscillate C, all of the pendulum will oscillate, okay, because the energy will be transferred. But okay, the one that we oscillate with maximum amplitude, okay, is D, because it has the same natural frequency with C. So then D will oscillate with maximum amplitude because it has the same natural frequency with C. Okay, can you understand that one? Are you clear about the resonance is different from damping? Damping, the amplitude will decrease. Okay. Resonance, okay, let's say you can the one that I give you example just now, okay, let's say you sing and your singing can reach the natural frequency of the glass near you, the glass will break. Okay, so for this one, if you swing C, C is actually the same length as D, means C have the same natural frequency as D, right? So when you try to oscillate C, it will transfer the energy to all of the pendulum, but D will oscillate with the maximum amplitude, okay, because it has the same natural frequency with C. Okay, can you understand about the one that I said just now? You want me to repeat again?
Yes, sir.
Yes, me repeat, or yes, you can understand.
Repeat again. Repeat again.
Okay, all right. So now let's say if I oscillate C, right? Okay, I oscillate C. Okay, I push C, so C will start oscillate. Okay, so B also will start oscillate, E also will start oscillate, D also will start oscillate, A also will start oscillate. Okay, but okay, the one that will move with maximum amplitude is D. Okay, why? Because they have the same length. Okay, so means if they have the same length, they have the same frequency. Okay, so it have the same frequency. So D and C has the same frequency. Have same frequency. So since they have the same frequency, okay, so D will oscillate with maximum amplitude. Okay, because okay, the frequency of the natural frequency of D has been reached. Okay, so can you understand that one? You want me to explain again?
Can, sir.
Okay. So others, are you okay? Quiet je. Diam aja. Are you okay?
Okay, teacher.
Are you worried because of the presentation?
Kind
Okay.
teacher.
Yeah. Even for M also worried. Okay, so alright. So here he said when pendulum C is pushed. So the pendulum P is pushed. What happened to others pendulum? So others pendulum also will oscillate. So other pendulums also will oscillate. Okay. And why? Okay, because the energy being transferred. Okay, because the energy being transferred. Okay, for D it says which pendulum oscillate with the largest amplitude. So the pendulum that oscillate with the largest amplitude is D. Okay, because of what? Because they have the same length, means they have the same frequency. So same frequency means D will oscillate at the maximum amplitude if you push C. Okay, so let's say if you push D, then C will oscillate with the maximum amplitude. So this one we call it as the resonance. Okay, so just now I give you example. If you sing, your sing frequency of your singing can reach the frequency of the glass. Okay, the natural frequency of the glass, then your glass will break. Okay, so that is another example. Or maybe you scream, then suddenly your window break. Okay, so means you reach the natural frequency of your window. Then that's why your window start to vibrate, then it will break. Okay. Alright, the next one. Okay, so this is actually the answer. Okay. Which two pendulums we continue to oscillate when the other pendulum have stopped? So what do you think? Which one we continue to oscillate? Okay, other pendulum already stopped, but the two of the pendulum will still oscillate. So which one you think? Anyone?
B and C.
Yeah, D and C will keep oscillate. Right? D and C will keep oscillate. So the answer is D and C will keep oscillate. Right? Why? Because their natural frequency, okay, is same. Okay, so the two of it will keep oscillate because they have the same natural frequency. Okay, so the answer is D and C. So what happened when the resonance occur? So when the resonance occur, the system will keep oscillate. Okay, the system will keep oscillate. So that's the answer, right? Even other pendulum already stop, but the other two will keep oscillate because they reached their natural frequency. Okay, they reach the natural frequency. Okay. Alright, so the turning forks, okay, the resonance and the beat frequency. Wait for a moment, I adjust the video first. Oh, cannot because here got words. Already. Wait. Okay, so just let's watch the video. Okay. So turning forks, okay, resonance and beat frequency. Alright. So this is two turning forks, okay? So the identical turning fork. They use the two identical turning forks, alright? So means identical, they must have the same frequency. Okay, so both of it must have the same frequency because they are identical turning fork, right? Okay, so you can see even you stop the, let's say turning fork Q here. So this is turning fork Q. Okay, turning fork P still produce the sound. Okay, so this means, okay, when you hit or you strike the turning fork Q, so when it vibrate and produce the sound, okay, when you produce the sound, okay, since they have the same natural frequency, okay, this one also will vibrate. Okay, so this one also will vibrate because both of it have same frequency. So when you hit, okay, when you strike the turning fork Q, it will make a sound, it will produce the sound, and this one also will produce the sound because they have the same natural frequency. Okay, so even you stop it, this one still can produce the sound, right? So let's see again. Okay, so you see because the second or turning fork P, right, to keep vibrate and produce sound. Okay, now it put weight here. So when you put weight here, now they are not identical anymore. Means they are not same in frequency, right? So what happen if you hit the turning fork, okay, you strike the turning fork. Oh, sorry. Okay. So can you see any sound produced from the turning fork P? No, because now they don't have the same frequency. Okay, so the P turning fork P will not oscillate. Alright, so I explained again just now. Okay, so you strike the turning fork Q. So let's say this one is Q, this one is P. Okay, so before this, both of it is identical. So identical means they have the same frequency. So when you hit the turning fork Q, the turning fork Q will vibrate and produce the sound. Okay, so then the energy will be transferred, the sound energy will be transferred by the air molecule. Then it will make the turning fork P also vibrate. Okay, because they have the same frequency. Okay, so means this one is the resonance. Okay, so it can produce, the P can produce the sound. Okay, because of the frequency is same with Q. Alright. Okay, then if I put the weight, when I put the weight on P, now they are not identical anymore, right? So means the frequency P is not same as Q anymore. So when I hit, okay, when I hit the, or when I strike the turning fork Q, okay, I will see that there is no sound produced by P, because now they are not identical, they are not in the same frequency anymore. Okay, so means there are not, they didn't reach the resonance. So resonance reach, okay, when you can reach the other object. So that's why just now you hit the Q, right? Q is the, has their own natural frequency. So when you hit the turning fork Q and the sound that you produce, okay, the frequency produced is same as the P, okay, so then the P will vibrate and produce sound. Okay, but now they have different frequency because they put the weight here. So means now the natural frequency is different than Q. So even when you hit Q, the P will not make any sound because it not reach the natural frequency for P. Okay, so if you reach the, if the, that's, you can simplify it like this, right? So if you hit any object, okay, if you hit any object, and the transfer energy and the transfer energy is same, okay, so the P will start vibrate, it will start vibrate with the high maximum amplitude. Okay, so that's the concept. So in the turning fork here, okay, if you hit Q, so Q will vibrate, okay, it will transfer the energy and it has its own frequency. Okay, so the frequency is same as P, then P will vibrate. But let's say they don't have the same frequency, they now, because they are different, they have weight here, so now both of it have a different frequency. So if you hit Q, P will not be vibrate, okay, because now the frequency is not same anymore, so there will be no resonance. The resonance only occur when you reach the natural frequency. Okay, so that can be a resonance. Okay, so are you clear about the resonance? You want me to repeat?
Understand, teacher.
Understand? Others? Very quiet. Don't worry, we still got 10 minutes. We still got 10 minutes. Okay. Okay, why does the turning fork Q produce sound without being struck? Okay, explain. Okay, so both turning, okay, have the same frequency. Okay, because they are identical. Okay, so the vibration of the turning fork P force turning fork Q to vibrate in resonance with P. Okay, so the vibration of turning fork P, okay, after you hit it, so it will vibrate. So it forced the turning fork Q also to vibrate because they are in the same resonance, mean they are in the same frequency. So energy is transferred from turning fork P to turning fork Q. So there is a sound energy being transferred, means by vibration. Okay, vibration of the air molecule. Okay, so the air molecules surround the turning fork P will vibrate. Okay, and it will transfer the energy to the another molecule until it reach the turning fork Q. Okay, then the turning fork cue will vibrate and produce sound. So the turning fork cue will vibrate with maximum amplitude and produce sound that can be detected. So we see the video just now. Okay, when it hits P, Q also we produce the sound. Okay, so because of they reach the natural frequency, and the natural frequency is same, and the process we call it as the resonance, right? Okay, so this is example also how to produce the frequency. Yeah, because it start vibrate because you give the frequency, right? Usually when you give a frequency, there will be an energy being transferred. Okay, then if you rub too much, okay, then it will reach the natural frequency of the glass. Okay, let's say you rub the glass, right? You rub the glass, okay, then until it reach the natural frequency, the glass will break. So you can play music by using your glass. Okay, so that is actually to produce the frequency. See, just use a glass. Alright.
Well, I got see this, but then they will hit the glass with the stick. But this fellow using his finger.
Oh, so this one they must know what's the pressure, right? The pressure to press the glass and the moisture of their hands. Okay, so the friction. Okay, so not everyone can easily do this one. Okay, very nice. Usually the only gifted person can do it like this. If me, I think all the glass already broke. Okay, so alright, so that one you can search in the YouTube. Okay, so let's answer this question. Okay, so please answer this one.
The system vibrates at natural frequency if it forces the same frequency.
Yeah, wait, I cannot hear you because of the music. What is it?
Oh, sorry, I didn't mean to. I actually turned on my mic. I was reading a question.
Okay, okay. Okay. I give like 30 seconds because after this, it's time for you to present already. One 1 minute 45 seconds. I will stop. Okay. Okay. So we see the question, the first one. So a system vibrate with natural frequency. If forced vibration of the same frequency is given to the system, so what will happen? So the answer, the resonance. Okay, so resonance. Right? So you give a force, okay, with the same frequency to the system, so the system will vibrate. Okay, it vibrates with the maximum amplitude. Okay, so just like the pendulum just now, you give a force to the pendulum B, right? So when you give the force to the pendulum C, sorry, to give a force to the pendulum C, and then the pendulum D also will keep oscillate, okay? Because you give the energy with the same frequency to the pendulum D, so it will oscillate. Okay, so that is actually a resonance. Okay, and for number two, it said a system has a natural frequency of oscillation equals to F. So an external force is applying energy to the system to perpetuate the oscillation of the system. So resonance will occur in the system if energy supplied to the system at the frequency equal to F. Okay, the frequency must be same, right? The natural frequency, both of it must be same. Then the resonance can occur. Just like now when I said if you can sing and you're singing, okay, it's same frequency with the glass, okay, frequency of the glass, then the glass will break. Okay, so anything, any objects around you, they have their own natural frequency. So if you can hit or you can reach their natural frequency, the object will vibrate. Okay, so when the object vibrate, okay, let's say for the glass, it will break. Okay, so that's the example. So that is the resonance. Okay, so let's check the answer. Yeah, very good, very good.
Teacher, I couldn't answer. There was no space for me to answer.
Really?
Yeah,
Before I
Tisha,
close the
maybe you have to
submission, is it?
refresh.
yeah,
Yeah,
I
because of,
did.
oh,
But
you did.
then nothing happened, so I don't know.
Oh, sometimes the connection, the internet connection also. Okay, means if that happen, you have to log out, then log in again. Okay.
Okay, teacher.
All right. So are you ready?
Teacher,
Teacher, why are you so excited, teacher?
I'm so excited, because it's been so long. I'm talking alone, Now I can hear someone talk. I was like, wow, so exciting. Okay.
Teacher, we also got respond in class, so consider talking
No,
also.
I only heard weekend voice, only weekend like giving me the voice. Before that, I was like talking to the text. Oh, okay. And then I talk again, then I read the text again. Okay, so let's continue. Okay, so actually this is a way of name. So I just see, okay, who knows who is the first one, the lucky one. Okay, so let's start. Okay, Rindya. Okay, Rindya,
Yes, teacher.
are you ready?
We'll see.
Okay. All right, go, go. All right. So,
Oh my
are you
god.
ready with your PowerPoint?
Yeah.
Okay, I will stop share my screen.
Okay.
Okay. All right. So, I will mute. All right. So, good luck. Okay, all the best. Okay.
Teacher.
Yes.
Teacher, you're
Um,
making it like competition, dear.
Hey, it's a competition, to get marks from me. Yes. What is it?
teacher, when present is to present a window, right?
To present, yeah, you present you can share the entire screen or you can
Oh,
share the
okay.
both also can. Okay.
Okay.
But video you have to share using a tab because if not you cannot play the video.
Okay.
The total mark is 100 marks. Okay. So I give you a quick okay explanation. So the PowerPoint, okay, for and the video, okay, and the principle, okay, the physics principle you use, how you explain, and the procedure, how to you explain the procedure and your creativity, and another is your presentation. Okay. So 100 marks. Okay, so we see because yeah, your PBL is 100 marks. Okay, so let's see. Okay, bye. Okay.
Okay. Can you all see the presentation? It's not full screen yet, but can you all see it?
Linda, you can make it full screen by
Yes.
pressing the
Yeah,
two
but
arrows.
now you all can see, right?
Yeah, can.
Okay. Okay. Hello, everybody. Good morning to all of y'all and my teachers. Sorry, my teacher. Y'all know who I am. I'm India from Class 4S, and I'm going to be presenting my magnetic propeller. And during this project, I was guided by my physics teacher, Juan Luis Valina. Okay, so to do the magnetic propeller, I used two magnets, A4 colored paper, screw, battery, metal wire, and a pair of scissors. Okay, before that, can you hear the sound? Do you hear the music?
Yes.
Yeah.
Yes.
Okay, so you'll watch the video of how the propeller is made and then I will explain in detail. Okay, so if you notice first, I prepared all the materials that I've shown just now, and then you cut the paper into like tiny squares, and then these papers are placed between the two magnets. And if you notice, there was a screw, and there was also another wire. You guys know that screws are conductors, right? So why do you need the screw when you have the metal wire to conduct the energy? Basically, in my opinion, I think the screw was used to like hold the model together because obviously when the screw touches the magnet, the whole screw is magnetized. So therefore, you can attract the battery and it holds the whole model together. But the screw is not really conducting the energy because not all screws are good enough to conduct the energy. Therefore, you need another wire, and that conducts the energy, right? So, the concept that I chose for my magnetic propeller is magnetic field. So, like I mentioned, the metal wire that is used It actually acts as a switch. If you think about it, when there is no connection between the metal wire with the battery and the magnet, the propeller won't move. But when there is a connection, when there is a complete circuit, the propeller will start to move. So this like metal wire, it acts like a switch, right? So when this switch is fully connected, meaning everything is connected properly, it's a complete circuit, there is a direct flow of current, right? So when there is a direct flow of current, all the electrons are moving in a straight line in one direction. And when this happens, there is a magnetic field that is formed around it. This magnetic field, it produces electromagnetic force, which is what causes the propeller to rotate. So when the propeller rotates, the electromagnetic energy is being converted to kinetic energy. In easier words to explain, first it starts with potential energy because the magnetic propeller, it has to be at a certain height. And then the chemical energy from the battery then converts to electrical energy, which is from the metal wire, and then it converts to electromagnetic energy, which is near the magnet, and then kinetic energy when the propeller starts turning because there is a complete circuit. Okay, I made two modifications. The first one was I had to change the magnets. So when I first did the model, I noticed that the propeller was not turning in one direction, but instead it was moving back and forth. And I did like some search about it, and I found out that it is probably because the magnets that I used were two different magnets. They had two different strength, magnetic strength. So when there is two different magnetic strengths, two different magnetic fields are formed. So at one point, this magnetic field will like cancel out each other. So when this happens, when the propeller turns and when it reaches the point where these two different magnetic fields cancel each other, it will repel and it will start moving the other way around. And then the same thing happens. It touches the place where it cancels out each other, it repels, and then starts moving the other way around. That was my first modification. So I had to use the same type of magnets with this exact same magnetic strength. And the second one was I used a metal wire instead of a copper wire. And copper wire is actually very easy to find. You can find it in any wire that you have at home. So why I use metal wire is because when I used copper wire, I noticed that I started to get shocked. Yeah, because at one part it was very hot, and when I touched it, I did get shocked. So because it's so dangerous, and after getting scolding from my mom, I decided to change to metal wire because it's a lot safer. And metal wire is also able to conduct electric. Obviously not as good as copper wire. Copper wire does it a lot better, which is why there was shock. But metal wire also helped to um, complete the model. Okay, so this is how the magnetic propeller works. Now let me guys watch it. Okay, that is how it works. And these were my references that I used to do this project. And that's it. Thank you. Thank you.
Okay. So for the question part, okay. Okay, for the
Yeah.
question part, can you go to the one when you explain about the how does it work?
Okay.
Can you open this share the screen?
Okay. Hmm. Is it
Uh,
this one?
yeah, that one.
Yeah. Okay.
Okay. It's very interesting. Okay. But it's very interesting. Like how does it work? Okay.
Mm-hmm.
But is it okay if you use a diagram? Okay, maybe you can that draw like something to show that actually how does it work. Because like if you talk like that, I'm sure like your
Oh.
friend also like imagine like where's the current electron, where does it
Oh.
come from, right? So maybe not now. Okay, I give you
Uh-huh.
some time to prepare. Okay, to
Mm-hmm.
explain about that one. Okay,
Mm-hmm.
so later then you're maybe after all your friends. Okay, because you're only 16 people, so it's I
Yeah.
think that 2 or 3 weeks we can finish.
Mm-hmm.
Okay, so you can present to me again about how does it work. Okay, just show a diagram. Okay, a simple one. Okay, to explain
Mm-hmm.
because your explanation is very good, but it's hard to see you to imagine. So please show
Okay.
me the diagram. Okay.
Okay.
All right. Thank you. Okay. Very good. Okay.
Thank
Right.
you.
So the next one. Okay, Eugene. Eugene, are you ready? Eugene?
Teacher, no, actually
No.
no. Because my folio my presentation got one some mistake.
The mistake. So when you can present?
Next lesson
Next lesson. For me, next lesson
uh,
after holiday. Okay. So after holiday, Eugene will be the first one to present. Okay. So after holiday, make sure everything ready. Okay. Is it okay?
yes teacher.
Okay. So let's move on to the next person. Tava, you are not ready yet, right? Cannot
Yeah,
see the
teacher.
wheel. Oh, I'm
I
sorry.
can't see the wheel.
I forgot to share. Tava, you're not ready yet, right?
Yeah, teacher.
Okay, so we go to the next one. Okay, Asha. Okay, Asha. You're lucky number
Yes,
two.
teacher.
So can you present?
Yeah, okay, give me a second.
Okay.
Hey,
Alright, wait, I stop share my screen.
is it showing? I can't tell. Oh, okay.
Yeah, yeah.
Okay. So good morning to everyone. What I have made is a flying saucer using Bernoulli's principle. So we'll first start off with making the model. So the first picture on the top left is the first concept that I was trying to use, but we didn't use that in the end. So it was quite easy to make. Just use like a piece of paper. Like you just need one piece of A4 paper, which is quite enough. And so you fold it into like can you see my mouse? You can't, never mind. You fold it into this like how I did, and you cut it. You cut the excess piece off, but still leave the other half longer than one half. And when you fold it over, you will get this kind of shape all the way to the top, right? And then after I got that shape, I was supposed to use a plastic straw, but I didn't have any straws. So I found a piece of plastic and made my own straw, something like that. And I put a hole in the middle, like right in the center of it, and put the straw through it. And then I put a back tail to keep it steady. And I used a tripod and a stick to um, put it on as to show the yeah. So Bernoulli's principle. In fluid dynamic, Bernoulli's principle states that an increase in the speed of fluid occurs simultaneously with a decrease in static pressure or a decrease in fluid's potential energy. Bernoulli's principle can be derived from the principle of conservation of energy. This states that in a steady flow, the sum of all forms of energy in a fluid along a streamline is the same at all points on that streamline. That requires that the sum of kinetic energy, potential energy, and internal energy remains constant. Bernoulli's principle can also be derived directly, directly from Isaac Newton's second law of motion. If a small volume of fluid is flowing horizontally from a region of high pressure to a region of low pressure, then there is more pressure behind than in front. This gives a net force on the volume accelerating it, accelerating it along the streamline. Sorry about that. So I have this small diagram here to show how it works. So the upper streamline, since it's going over the curve, it has a higher velocity, resulting in lower pressure, and the lower streamline has higher pressure because of low velocity, therefore creating a lift, making it able to fly up. So the modifications that I have done is I had to put a stronger stabilizer, so I had to use like a different type of paper so that it wasn't that flimsy. So I used that, and I had to use lighter material. I tried making a full model airplane, but it was too heavy. So I had to use paper instead, and I couldn't do a full model. I just had to do the wing and the tail. Okay, so now the video, but there's a problem. I can't put the video into the slide itself. So, teacher, how do I present my other thing?
Can you play the video, like using a video player?
Yeah, I can.
So just use the video player.
How do I switch to that?
Stop presenting first and then you.
Yeah.
Oh, okay.
Present using the Chrome, okay? Because not you cannot see the video.
Okay. Um. Wait, what? Okay. Can you see it? I can't tell.
No.
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 I'm not sure how to do this.
Did you upload in the Google
Yes,
Drive?
I did.
Your view?
Give me a second.
Okay, wait.
Okay, here we go. So let me just load this. Okay. So this is me using it. I'll explain over so
Can
you
you
can.
make it bigger? It's too small.
Oh, sorry. Okay, here we go. So this is me using it. So the way it works is that as you can see, the airflow is not pushing it from underneath, but from the front. But because of the way the wing is shaped, it is able to create a lift, and therefore it helps it fly. This is the same way that the wings of planes are made, so it's easier to
Actually, can you
fly.
play it again?
Again, okay.
Yeah.
Right, so that's how it works.
Okay, very good.
And teacher, do I have to show the references or done already?
Yes, show the references.
Okay, I need to switch the slides. Okay. So these are my references. Mostly I've taken them from YouTube, and I think I forgot to add a thank you screen. So yeah, that's it, I guess. Thank you everyone for yeah, thank you.
Okay, very good. All right. So actually, I share. There's something I want to ask. The modification, right? Did you put in the slide? What is the modification that you did?
Yes.
Yeah. When is the last time you cut your hair?
I think like
I think
what
it's a
6 months ago.
Saji question, not me. Okay. All right. So about the Bernoulli. So let's say this is actually for you use it, okay, in the wings of aeroplane, okay. Let's say for the car, okay. So let's say for the car, uh did they use the Bernoulli principle? Did any of it use the Bernoulli principle, especially in the racing car?
Yes, I think they did with the
Yeah.
way that it's made.
How?
For the curve, it's more curving on the top compared to the bottom, so that the higher pressure is below. Therefore, if it is fast enough, the car will feel lighter as it goes. Yes,
The car will feel lighter. Is it,
yes,
or
and
maybe because of the safe? Is it any other reason than the car can move faster?
I'm not sure.
Okay, all right. So it's okay. All right, very good, Asha. Okay,
Thank you, teacher.
okay. All right. So we still have time. Okay, we still have time.
Te- Teacher, we have no time. We only have 2 more minutes, teacher. Finish already.
Okay, what subject after this?
Chemistry.
Chemistry.
Oh, okay, yeah, chemistry. Okay, so I think we start until now. So only 2%, okay, can present in half hour. I thought like maybe 3 or 4. Okay, so never mind. That means maybe after this I will only like teach half an hour, another 1 hour you can present. Okay, so we continue after the school holiday. Okay. So there's a lot of time. So maybe you can prepare. Okay, you can prepare more. Maybe make your PowerPoint. Okay, better. Okay, because there's a marks for PowerPoint. Okay, and another one, for video. Maybe you can take a longer video. Okay, so I can see more. Okay, longer video. All right, and then the explanation, I hope you don't just read, okay? Please explain, okay? You don't just read. Just explain to me actually what is happened. Maybe you can draw the diagram, okay? So to make people understand. Okay, because some of this topic we didn't learn yet. So maybe some of your friend like, what does it mean? Okay, and after this, okay, after this session, your friends, okay, will ask you a question also. So there must be one question. So if you can ask your question, your friend a question, I will give you extra mark for people who ask the question. Okay, is it okay? All right. So I see you after holiday. So take care, class. Okay. Happy holiday. I will not give you homework. Okay. So, like Sajif asked teacher, no, no, no. You ask your friend about the project. If you ask your friend, I give you mark. Okay, for the question. Yes. You have, but mean the question must be like a logical question lah, not like Sajif questions. Yeah, we can type. Yes, you have to type. You can type. Yeah.
Teacher,
Yes.
I hope you don't mind, but what if this Saturday
Yeah.
we all like have a session?
No, teacher, weekend is a dream.
Teacher, I think
I
Because okay,
teacher.
if I do on Saturday, there will not for S only. For M, for K also will be there.
No,
Teacher,
only
only for us separated.
Weekend is different class. Sorry, teacher, weekend different class.
Teacher, I think we can, teacher.
All right, so we continue after the school holiday. All right,
Let's
okay.
go, teacher. That's the way.
Because, all right, okay. So see you on. Okay, so take care, class. Happy holiday, everyone. Okay.
Thank you, teacher.
Bye.
Teacher.
Okay.
Bye, teacher.
Happy holidays. Bye.
Bye. Chinese teacher.
Yeah.
Teacher. But most of them choose Form 5 topic.
So if you means you have to study. It means let's say you see when they present, right? So when you present, you have something to ask. Just now, like India, right? You cannot imagine what is actually the magnetic field. Where does it come from? Then you can ask. So that's why they can be more prepared, okay, when they present. So I mean they have to know what they talk about.
Okay.
Okay.
Thank you.
All right. Bye bye.